Chapter 8 Chemical Equilibrium, 2nd hour, Part 3, 8.2 Equilibrium Constant, Kc and Kp. At the end of the lesson, students should be able to calculate Kc, Kp or quantities of species present at equilibrium. There are two types of calculation involving equilibrium constant. We will focus on calculation of type 2 in this video. If you want to know the calculation of type 1, you may refer to the previous video, chapter 8.2 hour 2 part 2. For type 2, the initial quantities, either initial concentration or initial partial pressures, and Kp or Kc are given. Then we can solve for equilibrium quantities, either concentrations or partial pressures. For calculation of type 2, we need to have an ice table, which is initial, change, and equilibrium table. From the ice table, we can express the equilibrium concentrations of all species in terms of the initial concentrations and a single unknown x, which represents the change in concentration. Next, write the equilibrium constant expression in terms of the equilibrium concentrations. Then insert the value of equilibrium constant and equilibrium concentrations of all species into the Kc or Kp to determine the x value. After we determine x value, we can calculate the equilibrium concentration of all species. Example 1. At a constant temperature, 0.100 molar of iron thiocyanate is dissolved readily in water to give a red solution. Iron thiocyanate ion produce iron positive 3 ion and thiocyanate ion. At equilibrium, the concentration of iron thiocyanate ion have dropped to 0.02 molar. Calculate for the concentration of iron positive 3 ion and thiocyanate ions present at equilibrium and the value of Kc. To solve this question, we need to build ice table because the initial concentration of iron thiocyanate ion is given. First step, we write down the balanced chemical equation. Second, we build the table and label the first column with initial, change, and equilibrium concentration. Next, we insert the value of initial concentration for all the species. For iron thiocyanate ion, the value given in the question is 0.100 molar. On the other hand, the initial concentration of products are 0. Next, we express the change of concentration in x based on the stoichiometry coefficient. For iron thiocyanate ion, the change is minus 1x because concentration of reactant decreases with the reaction proceed. For iron 3 positive ion and thiocyanate ion, the change is plus 1x because the concentration of products increases with time. Then the equilibrium concentration equal to initial concentration plus the change in concentration. Since the equilibrium concentration of iron thiocyanate ion is given in the question, which is 0.02 molar, so we can determine the value of x. After we solve the value of x, then we can calculate the equilibrium concentration of iron 3 positive ion and thiocyanate ion. Lastly, we can insert all the values of equilibrium concentration into Kc expression to determine Kc value. So the final answer is 0.32. Example 2. At 1000 degrees Celsius, the equilibrium constant Kp for the reaction 1 mole P2Y6 produce 2 mole PY3 is 20.4. If the initial partial pressure of P2Y6 is 0.4 atm, calculate the partial pressure of this species at equilibrium. To solve this question, we also need to build the ice table. First, write the balanced chemical equation. Then, build the table and label the first column with initial change equilibrium partial pressure in unit atm. Then we insert the initial partial pressure of P2Y6, which is 0.4. The initial partial pressure of PY3 is 0 because there is no product formed at the beginning. Next, we express the change of pressure in X based on the stoichiometry coefficient. For P2Y6, the change is minus 1x because the pressure of reactant decreases with time. The change of product PY3 is plus 2x because when 1 mole of P2Y6 reacted, 2 mole of PY3 was produced. Then the equilibrium pressure equal to initial pressure plus the change in pressure. Next, we write the Kp expression and insert with all the equilibrium pressure values. Then we need to solve the quadratic equation to get the value of X. You can either use the formula or insert the quadratic equation in your scientific calculator to get the X value. From the two values of X obtained, we have to choose the positive value as the valid X value and ignore the negative value. Finally, you can calculate the equilibrium partial pressure of PY3 and P2Y6 with the valid X value. Thank you for watching this video.